In this lesson, we're going to be talking about buffer overflows. A buffer overflow is where you've got a chunk of data in memory and you're really trying to cram too much data into the space that's available. I've got a program here that I've written, just a really junky program, very poorly written by design, because I want to have some vulnerabilities here that I can exploit. This is just a C program. I'm including a couple of headers, and now I'm starting my main function. I have declared a char array that's 256 characters, and another one that I'm calling copyloc, and I'm going to say that's 36 characters. Now, the idea behind these two is I'm going to load this bigger one up and then try to copy it into the smaller one. The first thing I do is I print out a prompt saying enter me a value, and then I take that value in, and I load it directly into the character array. Now here's where we're going to kill the stack. We're going to execute a string copy, and this is the weak version of string copy. If I were to do this in a real program, I would use string end copy, which would give me the ability to say only copy this many bytes. I'm going to copy the character array into the copy location. And then I'm going to print out the copy location. What I want to do here now is I'm just going to run this program. So you can see if I just give it a reasonable value, not a big deal. If I give it a really large value, what's going to happen is I'm going to try to put too many characters into this space. And because of the way the stack works, what I'm doing is I'm actually overwriting some segments underneath the value copyloc. What ends up happening is eventually we're going to write over the place where there's a pointer saying once you're done this particular function, jump back to this location. So that's the instruction pointer. And we store that instruction pointer temporarily when we call a function. If we were able to write over that stored instruction pointer, we might be able to influence how the program actually operates. You can see stack smashing detected, and it terminated buffer with a core dump, and the segmentation fault is saying you're trying to go someplace that you don't actually have rights to do. This is how a buffer overflow works. You provide too much data to a buffer, and in this case, the char array is our buffer, and the one that we're actually overflowing is this copyloc here, and that's only 36 characters. As soon as I get beyond 36 characters, I run the risk of doing something really bad just because of the way the stack works. There's nothing that prevents me from writing a whole lot of data to the address that starts where this is. Now I'm going to start at that location, and I'm just going to keep writing until I run out of data, regardless of what the program believes may be at other locations. When the program goes to access something that may be stored beyond this, I may have overwritten it with all of this A data here. All of these A's are being dumped into the address that begins where this copyloc is actually in memory. And again, that's only where it begins. It doesn't say anywhere here where it ends. Where it ends is when I run out of data. There's a potential of writing over a lot of things, including, as I said earlier, the instruction pointer. And if I were to overwrite it in a particular way, I could tell the program to hand over control to another piece of memory. And what I might do is I could actually load up potentially some executable code and have the program jump to that particular location, and it would run the program that I had written into memory. And I would do that here somehow by putting in bytes that would actually be executable if the processor were to be handed them. That's how a buffer overflow actually works.